Hey guys, so this lecture is going to be on restorations and reintroductions. And an ecological restoration is the process of restoring the species and ecosystems that occupied a site at some point in the past, but were degraded, damaged, or destroyed. And restorations can happen for a number of reasons. Because many degraded areas are unproductive and of little economic value, governments will be more willing to restore them in order to increase their economic productivity and their conservation value. So for example, a degraded area may be the subject to soil erosion, and it could contribute to flooding. So restoration in these cases would be motivated by a desire to mitigate those threats to human life and human property. Businesses are also required by law to restore habitats that they've degraded through activities like strip mining or waste disposal. Governments sometimes have to restore ecosystems that have been damaged by their own activities, so including dumping, sewage in rivers, and in estuaries. Pretty much anything that they do that harms the environment, they are required to mitigate that. And then restoration efforts are often a part of a mitigation or a biodiversity offset. So a lot of the times a new site that's incorporating, usually like wetland communities are the ones that fall into this category, is created or rehabilitated to compensate for a site that's been destroyed somewhere else by development. And other times, it's actually for ecological processes rather than the ecosystems that need to be restored. So, for example, annual floods disrupted by the construction of dams and levees and natural fires that we stop from fire suppression efforts might need to be reintroduced if the absence of the processes is proving to be harmful to species or the environment. So in some cases, the high prevalence and removal of invasive species has also caused natural resource managers to use ecological restoration. And it's pretty much the most effective tool in increasing the area of the ecosystems dominated by native species in order to combat those invasive species. So often the goal for restoration efforts is to create ecosystems that are comparable in their function, their species composition, and their ecosystem to existing reference sites. And a reference site, it kind of acts like a control in a scientific study. So it shows us what the ecosystem should look like, and it allows us to set goals for restoration. So we would look at a site that is very similar in structure, and use that as a reference for how we are going to do this restoration. To use a reference site doesn't mean that the restoration goals are set in stone, though. So we don't need to make it exactly like it. Ecosystems change over time. So that could be due to things like climate change, plant succession, the abundance of species varying, pretty much any factor. There's a lot of things that change over time. And in order to make it realistic for your restoration, in order for it to be maintained over time, the goals of your restoration also have to change over time. So it needs to change with the environment that's changing around it. And one really important question for these restorations is the ecological assembly order. So what that is the order of when and what species we should place into an ecosystem that we're restoring. So this it can be species components, it could be like anything in your ecosystem. So what order do we build up the ecosystem? So sometimes it's kind of obvious what we would put first. So for example, if you had a predator that needed a well-established prey species, you're going to be putting the prey in there first, right? But it's not always that simple. The decision, there's a lot of overlaps in the decision. So the functional relationships of species aren't just one species and another species, right? There's a lot, it's a web, there's a lot going on. So to decide what goes first is a really hard thing to do. So for example, if you had a park in Africa that was degraded, it might have more than a dozen different ungulate species that have very similar roles in the environment, but deciding what order they're going to be reintroduced is the problem. If they all provide very similar roles, which one comes first? Which one do we focus on first? Which one do we leave for last? So it's important to have a pretty good knowledge about the specific ecology of individual species, and that can help guide with some of these decisions. Often when you're restoring a large area, they will actually test out different methods of restoration in smaller patches. And that's so they can figure out what method is the best. So this image here it was an experiment to test the effects of different treatments on the restoration of a Friendship Marsh in California. And the marsh was divided into 6 experimental units. So there were 3 with tidal creeks, 3 without creeks, and they were testing the effects of drainage. So with each unit, the restoration treatments in the small squares involved different species too. So they had different densities of species, different soil additions. And in the larger blocks, the salt marsh grass was planted with or without a kelp compost. So all of these little different things, they were changing up within each area in order to determine what the best combination really was. So the impact of these treatments on plants and fish and invertebrates and even algae were all being evaluated here. It was looking at the impact of everything. And these test areas, they would monitor them for years or sometimes even decades to determine really how well the management goals are being achieved and whether or not they need further intervention or they need different methods because maybe none of them work. So they would do this for a while to determine what method is really best. Now, restoration ecology provides theory and techniques on how to restore various types of degraded ecosystems, but they have 4 main approaches to how you're going to help an ecosystem. So the first approach, which is this red line here, that one is no action. So when that happens, it's because restoration is deemed either too expensive or a previous attempt to restore that ecosystem has failed, or experience has shown that the ecosystem is actually going to recover on its own over time. So letting the ecosystem recover on its own is also known as passive restoration. It's typical for old agriculture fields in eastern North America, like where we live, where the field over time is going to return back into a forest after a few decades after being abandoned. So you don't really need to put in the money and the effort to do that for the ecosystem since it's going to do it on its own. So that's passive restoration, just letting it restore on its own. Then you have rehabilitation. So rehabilitation is when a degraded ecosystem is replaced with a different but productive ecosystem type. So, for example, a degraded forest might be replaced with a pasture that was productive, and just a few species might be replaced. Sometimes it's larger scale. Sometimes there's a lot of species being replaced, but it's really about the aesthetic enhancement of the disturbed lands, and the elements and structure and function of the ecosystem are not really as important to be in the original condition. It's about bringing it back to being productive without worrying about making it the same as what it had been. And then you have the third type, which is partial restoration. So that's this blue line here. And partial restoration, at least some of the ecosystems and some of the original dominant species are restored. So this would include, for example, replacing a degraded forest with a tree plantation, or replacing a degraded grassland with a few species that can survive. Partial restoration typically focuses on dominant species or particularly resilient species that are critical to the ecosystem function, and it delays action on those rare and less common species that would be part of the complete ecosystem restoration. So then we have the fourth type, which is really the ideal type, is complete restoration. And this is when the area is completely restored to its original species composition and structure by an active program of site modification and reintroduction of the original species. So restoration first has to determine what the source of the degradation was. So what caused this community to fail in the first place? And it needs to mitigate that. So it needs to get rid of that issue. And for example, so if you had a polluted lake ecosystem, you first have to identify the source of the pollution and get rid of that source before you can restore it. Otherwise, you're going to restore it and it's just going to fail again. So you want to give it the best chance you can before you go through the restoration. You also must establish natural ecological processes. So they're going to help the system recover for you. So by establishing those processes, it's going to speed things along and it's going to be a helping hand in that. So obviously, a full restoration is the most desirable scenario. You are completely bringing it back to what it was supposed to be at. But the problem is it's also the most difficult and the most costly. So it's very hard to do that for every ecosystem, which is why they have these other options. So the partial restoration, rehabilitation, or even no action. Those are all other options for when you can't afford to fully restore an ecosystem, or when you just don't have the resources for it. So there is an idea called gap analysis that kind of tells you what you should focus on protecting and restoring. So the goal of the gap analysis program is to keep common species common by identifying those species and plant communities that aren't really adequately represented in existing conservation lands. So common species are those that aren't currently threatened with extinction. So this is not looking at species that are threatened or vulnerable or anything. This is just the most common species. And by identifying their habitats, gap analysis gives land managers and policymakers the information that they need to make a better informed decision when they identify the priority areas for conservation. So a lot of this gap analysis is going to include looking at GIS, so geographic information systems. So they're able to layer the maps of the distribution of species, protected areas, vegetation types, all of this, and they're able to see how they overlap and see what really needs the most help right now. For example, in this image here, the distributions of endangered animal species and protected areas are overlapped to highlight areas that might need additional protection. So the overlap maps show that the distribution of species A is almost completely protected in a conservation area. Species B is protected in a small amount of their range, but species C isn't protected at all. So using gap analysis, we would determine that species C is the one we need to work on to protect. So it's not going to matter which one is more rare or which one has less species, I mean less individuals in the species. It matters which one isn't being protected right now. So they would move to protect C instead of A or B. So what they would do is they would just establish a new protected area to include the range of C. That will be their highest priority. So sometimes this isn't really the ideal way to do things. Again, there might be species that are not being protected right now, but don't necessarily need it. Maybe they are thriving and they don't need to be in protected areas, whereas maybe species B, who is only partially in a protected area, is doing terribly and it needs our help more. So there's a lot that comes into play when deciding what to protect, but gap analysis allows us to identify any of those things that we might have missed. So something important when it comes to restorations are Superfund sites. So there are thousands of contaminated sites that exist all over the nation, and it's usually due to like hazardous waste being dumped or any sort of hazardous degradation. So they're usually left out in the open, improperly managed, and they can include like manufacturing facilities, processing plants, landfills, mining sites. All of these things are really kind of hazardous areas that need to be restored. And in the late 1970s, toxic waste dumps received national attention when the public learned about the risks to human health and the environment that were posed by those sites. So, in response, Congress established the Comprehensive Environmental Response Compensation and Liability Act, or CERCLA, and that was in 1980. So this is informally called a Superfund. And what it is it allows the EPA to clean up contaminated sites. And it also forces parties responsible for the contamination to either help perform the cleanups or reimburse the government for the EPA-led cleanup work. So if there's no responsible party that they could find, this Superfund gives the EPA the funds that they need and the authority to clean up those contaminated sites. So the main goals of a Superfund is to protect human health and the environment by cleaning up these contaminated sites, to make responsible parties pay for cleaning up the work, to involve communities in the Superfund process, and to return those Superfund sites to their productive use. So you can actually go online and you can go to this link here. It's in the PowerPoint that I uploaded to my courses, so you can click on it if you want, and you can search for Superfund sites near you, and there are a ton. So this is the map of our region. You can see there's a ton in New York and New Jersey. And even in Broome County where we are, there's quite a few. So you can see if there's any near your house. So there's really a bunch of steps to how this works. So there's like 9 steps that go into the Superfund process. So first you have your preliminary assessment. And this stage includes a review of historical information and includes visiting a site that's a site to evaluate the potential for a release of the hazardous substances that are there. So the EPA determines if the site poses a threat to people and the environment, and whether hazards need to be addressed immediately or if additional site information is going to be collected. For step 2, you have your national priorities list. So it's the listing process. And the NPL, or National Priorities List, is an information resource that identifies sites that warrant cleanup. So it's a list of the worst hazardous waste sites that were identified by the Superfund. And it's largely based on the score that the site receives from the hazard ranking system that they use. The next step is remedial investigation or a feasibility study. So this kind of characterizes the site, and that stage involves an evaluation of the nature and the extent of the contamination of the site, and it assesses potential threats to human health and the environment. So the stage also includes an evaluation of potential performance and cost of treatment options for the site. So it's really characterizing all of the possible issues with the site and how much it's going to cost to fix it. Then we go to records of decision. So this is when they decide how to remedy this. So the records of decision, or ROD, explains which cleanup alternatives are going to be used at the NPL site. And leading up to the issuance of the ROD, the EPA recommends a preferred remedy, and it presents a cleanup plan in a document called a proposed plan for public comment. So they leave it open to the public to comment on it, and following the public comment period, the EPA issues a record of decision. The next step is the remedial design or remedial action. And this is detailed cleanup plans that are developed and implemented during the remedial design stage. So this includes development of engineering drawings, specifications for a site cleanup, and it follows, the remedial action follows the design and involves the actual construction and implementation of the cleanup. Next, we have construction completion. So this is a little bit self-explanatory. This indicates that all of the physical construction required for the cleanup has been completed. So even though there might still be some final cleanup levels to do, the initial physical construction is done. So for example, a groundwater treatment system has been constructed through it. You may need to operate for a number of years in order to for all the contaminants to be removed, but once the whole groundwater treatment system is constructed, it's done, right? Then you'll be construction complete, even though you need time for everything to get back to normal. Then we have post-construction completion. Activities undertaken during this phase help ensure that the cleanup work at a site continues to protect human health and the environment. So that can include routine monitoring of a site, reviews of the site to ensure that cleanup continues to be effective, and enforcing any long-term site restrictions. So then the next stage would be the National Priorities List, or NPL, deletion. So once all of your cleanup goals are achieved, the site is fully protective of human health and the environment. The EPA will delete it from the NPL, so it's no longer listed. And on this map here of our region, you can see all of the green sites are ones that have been deleted. So these are ones that have made it to this stage. So the yellow are the ones that are still prior to that, and then the red are the ones that are still at the preliminary assessment stage. They have not been officially listed. And finally, we have site reuse/development. And the EPA's goal is to make sure site cleanup is consistent with likely future use of a site. So a consideration of reuse of a site can occur at any point in the Superfund cleanup process, but the EPL works with communities to make sure that sites or portions of sites end up being used safely. So this can kind of occur at any point where they decide what to do, but when it's fully completed, that's when they can start to use them safely. So something that comes into when we're looking at restoring sites are prescribed burns. And a lot of time we think of fires as being bad for the environment, right? We don't like forest fires, but there's actually, natural. They happen all the time in nature, and they need to happen for a lot of ecosystems for them to thrive. So in order to replace some of the fires that we have kind of stopped from happening, we do some prescribed burns. And sometimes we use them to reduce hazardous fuel loads, especially when you're near developed areas, to manage landscapes, to restore natural woodlands, and for research purposes as well. So they're kind of a way to allow natural effects of fire to occur while we're limiting the possibility of the fire spreading and causing issues for us. So, for example, in forests, controlled burns stimulate germination. And some desirable forest trees actually need these burns. So, for example, some cones for things like lodgepole pines, they need fire in order to open and disperse the seeds, or at least heat. They need extreme heat. So you can do an experiment with them if you have one. You can put them in the oven like this guy did. I'll fast forward a little bit. And as they get heated up, they open up and their seeds release. So there's a few trees that do this. It's the lodgepole pines will do it, sequoias will do it. So the heat causes their cones to open up and disperse the seeds. So controlled burns are also really important for prairies.
Looks like the temperatures have cooled down a good bit.
You will
so let's remove it from the oven and take a look.
To keep succession from taking over. So to keep the forest from kind of taking over the prairie. So getting into some examples of restoration plans, the Comprehensive Everglades Restoration Plan, or CERP, was authorized by Congress in 2000, and it's a plan to restore, preserve, and protect the South Florida ecosystem while providing other water-related needs to the region. So that includes water supply and flood protection. So it's estimated to be at a cost of more than $10.5 billion, and it has a timeline of over 35 years. So it's going to take a long time and a lot of money to do. But it's the largest hydraulic restoration program ever undertaken in the United States. And it's really important because the Everglades have suffered greatly from human impacts. So in the late 1800s all the way to around 1972, there were massive drainage efforts in the Everglades. So you can see here all of the drainage canals that we created. So we were draining the Everglades for agricultural, residential, and commercial development. Before we drained it, there was a ton of water in South Florida, and it wasn't really habitable by people. So when we drained all of the regions and we created these canals, it dried out a lot of the region, and we were able to build on it. So wetlands were drained or filled, the canals, roads, buildings, everything began to displace the native habitats, and it disrupted the historical water flow. So in 1948, Congress authorized the Central and Southern Florida Flood Control Project. It was a huge system of water management infrastructure, and it drained half of the original Everglades. And it's actually what allowed South Florida to develop into one of the most important economic regions in the country. Modern South Florida, including like Miami and Fort Lauderdale and West Palm Beach, they wouldn't exist today if it wasn't for that flood control project. They just simply could not be there. The problem is that the residents, commercial businesses, the real estate development, and Southern Florida's tourism and agriculture, and even fishing industries rely on the clean water that the natural Everglades provide for them. So we've kind of gotten rid of a lot of that. And it's not just an inland issue for people that are relying on the water. It's also coastal fisheries and waterfront real estate depend on the healthy estuaries for clean water as well. And with rising sea levels, the pressure from the ocean is causing more and more salt water to enter the aquifers down there. And they're losing some of their clean drinking water. It's becoming brackish. So by increasing the size of the wetlands in the Everglades, it's increasing the reverse pressure from the fresh water, and it's stopping salt water from coming in. And in recognizing the magnitude of the restoration effort and the critical importance of having partnerships with everyone, the state, the local governments, everything, the Intergovernmental South Florida Ecosystem Restoration Task Force was established in 1996. So the task force uses a restoration framework to organize and assess the complex effort that's needed to restore this area. So it includes 3 stages and 3 goals to this restoration. The number 1 goal is water. So to fix this issue with the water, to bring back the as much of the original flow as possible. And secondly come habitats and species. And then third is the built environment. So they're on their way to achieving these goals. It's a lot of work, but hopefully they'll bring it to what they want it to be. So originally there was all of this freshwater flow throughout the entirety of South Florida. And with the canals that we have, it's been pretty much cut off. So the idea is to restore this to similar to what it used to be. It's not going to be completely, but to get it a little bit better. And by increasing these wetlands is not only increasing the water flow and increasing the pressure into the aquifers to keep the salt water from coming in, but it's also going to help increase plant densities. And by increasing the plant densities, by increasing the mangrove populations, it's going to delay the effects of climate change that are happening down there where the sea level is rising. So the sea level eventually will rise and will take over part of this region. If we are allowing more and more plants to be restored and to create more and more soil for us, it's going to raise that level of land to enough that it will severely delay the flooding of ocean water. So it's really going to help in a lot of different ways. So when you're restoring an ecosystem like this or any ecosystem, it's often important to provide the proper resources for the species that are living there. So they may not be able to survive right away with the natural resources that they would have had originally. You may need to supplement. So you can do things like provide nest boxes for things like wood ducks and bluebirds, flying squirrels, bats, even owls. And you can provide platforms for birds to nest on. So osprey really depend on these. And if you're on your way into New York City and you look into the wetlands around there, or even a lot of places in New Jersey as well, you'll see a ton of these platforms out in the wetlands, and that's used for osprey to nest on. A lot of times you can also provide bat houses, so that's what these are. These are for bats to go into and sleep in, and sometimes they have ones that are used for hibernation, and that is to make up for the lack of caves available anymore. You also sometimes will provide food. So, for example, you can put out deer carcasses for eagles to eat. You can plant vegetation. We have planted a ton of milkweed to help monarchs in migration so that there aren't as many gaps in their migration and they're able to find milkweed pretty readily. You can have bird feeders or hummingbird feeders, wildflowers for bees, so a lot of different things. Water is especially important, especially in arid areas where there's not as much water. So a lot of times you can have things like water troughs for bats or water for like gazelles, pretty much anything that is going to need a decent amount of water available. And another thing that you don't really think of is sometimes you need to add things like social stimulation. So, for example, island nesting marine birds, they require a certain amount of social stimulation to trigger their proper reproductive cycle. And when they're declined in their populations, they might not have enough numbers to trigger that cycle. So you can add things like decoys and speakers that are playing the sounds that the birds would make in order to kind of trick them into thinking there's more of them there and to trigger their reproductive cycle. So there's a lot of things that you can do to help them that aren't necessarily natural, but it's the help that they need when they're in these situations. And if you're looking to restore an ecosystem, it's also important to remember you need to keep out the issues that caused the problem in the first place. So sometimes it's really hard to do. So, for example, on Oahu, introduced predators have decimated native populations, and the Fish and Wildlife Service actually built a predator-proof fence to keep the introduced cats and rats and mongooses out of some of the protected areas. So they have these fences that the introduced species can't get through. Now, this doesn't work everywhere. It works very well in Hawaii and on islands because they don't really have many or any native mammals, like ground dwelling mammals, that wouldn't be able to get over the fence. All of the things that aren't able to get over the fence are introduced. Their habitats are mostly compromised of birds, really. So there's really not much that is native that can't get through. But sometimes barriers like this don't work, right? You can't always just put up a wall and think, okay, that's fine, we're good. So with the increase of people like spelunking in caves and getting injured, a lot of caves were walled off in the 1950s. They built a wall in front of the cave so people couldn't get in. But these walls ended up leading to a steep decline in the cave-dwelling bat populations. So there, you can see it, the populations just shot right down. And it's because they can't get in and out of their caves. So to remedy that, they actually replaced the walls with grates. And people still couldn't get in, right? They're still keeping out the issue, but they are able to allow the bats to go through it now, so they can get in and out between the bars, and the bat populations shot back up. Unfortunately, white nose syndrome has been an issue, but this is actually kind of helping with that as well, because it's keeping people out. So it's keeping out people who might be tracking in spores from the white nose syndrome. So it's been pretty important to have a lot of these areas sectioned off. So now we're going to get into some reintroductions. So when you're establishing new populations, there's kind of three basic strategies to this. The first way to do this is reintroductions. So you can reintroduce a species to its former range. Then you can do introductions, which is when you're introducing an endangered species to a place outside of its native range. And that might seem kind of an odd decision, but there's three main reasons for why we do that. So sometimes we'll do it to establish new populations in case other populations crash. Sometimes we need to do it because their original habitat was destroyed and they need a new one. And sometimes it's to get them away from a threat that we can't get rid of. So we need to bring them somewhere else where the threat isn't there. So, and then we have our third type is augmentation. So the augmentation of an existing population is when you add individuals to an existing population, either captive or wild bred. And that's going to add genetic diversity. So the source of your individuals, like I just said, can be captive bred or wild caught, but there's advantages and disadvantages to each of these things. So when you're captive bred, the advantages are that they're usually more healthy, they're usually well fed, they have had vaccinations, they're abundant, they're readily available. They manage genetic diversity when they're doing captive breeding programs, and they can control the sex ratio that they release. But some disadvantages are that these animals might not really be acclimated to being in the wild. They might not have the learned behaviors for hunting and predator avoidance. And sometimes they have a lower initial survival rate because there's a learning curve to all of these things. Wild caught individuals, some advantages are that they already know how to survive in the wild, they know how to reproduce in the wild, and they might have better fitness. But the issues are that you're now depleting a wild population. So you're taking away from the wild. You're not really adding. You're just moving it. So you can also transfer disease because these animals are out in the wild. You don't know if they have any diseases necessarily. So you could be transferring them to a new population. And often there's mortality involved in transport and capture because it's a stressful thing to do to these animals. So a lot of times they will die. Now, when you're releasing them, there's a couple of methods for how you will release them. You can do a hard release, which is when you simply just take them and dump them in a new place. You just bring them somewhere and then leave them, and that's it. So this happens a lot when, like, the Fish and Boat Commission releases trout. They'll just dump them in the water and then leave. But then there's soft release. And this is when you release them gradually and you have some kind of continued care for a while. So in some cases, you'll release them into like a fenced off area. And some animals like carnivores need the fenced area at first because when they're released, they would run and leave the area. And this allows them to get used to the area before the fence is removed, and that way they stay in that spot where you want them to be. Another aspect of soft release, you could provide food, you could provide shelter, you can control predators. And I believe one of the extra credit papers that we have actually talks about a soft release that's been done. So if you want to learn more about that, there's one paper that talks about a soft release of a species of bird. And they actually provided them with the shelter and food, and it went pretty well. So when you're reintroducing a species, there's a lot of things to take into consideration. You really want to maximize their success. So there are several conclusions that you can make. It's much greater success when you have a habitat quality that is high or excellent. You have greater success when you put them in the core of their historical range, so their location is important. You have a greater success with wild caught individuals because, again, they already know how to survive in the wild. You have a greater success with herbivores than you do with carnivores. It's easier to control their food, right, and make sure that it's available. Their food doesn't run away from them. They don't need to learn how to hunt. You also have a greater success when you have more individuals. So, of course, the more you release, the better success you're going to have. And they looked at some reviews of ungulate reintroductions, and there were actually 3 factors that were particularly important. Having at least 20 individuals was important for ungulates. And it also came into sex ratios. So having a balanced sex ratio was important for them. And that's not always the case. It depends on the mating strategy of the species you're releasing, right? So you need to take their sex ratios into account. It also matters for the age and stage structure. So usually you want a high proportion of mature individuals that are of breeding age. So you don't necessarily want ones that are past breeding age. You don't necessarily want juveniles. And Again, this might vary a little bit with species, but in general, you want really those mature breeding age individuals. Another review actually looked at whether reintroduction led to self-sustaining populations, and as if you have 500 individuals, it actually leads to only like a 10% increase from 100. So really there's that like sweet spot in the middle for how many individuals to release. But you do want to release as many groups of individuals as you really can in different areas, because maybe one small population might go extinct, but the other ones might have what they need to survive. So even releasing at different sites, not just one single release. You can keep trying for successive years. You might have to release them in a certain season, right? So when to release them is important. So there's a ton of factors that come into this. So an example of a reintroduction that was relatively successful is the California condor. So this is the largest land bird in North America. They can have a wingspan of like 9.5 feet. They're huge. And unfortunately, we almost drove them to extinction. So the main cause for their decline was actually lead poisoning. And since these birds, they're scavengers, they would frequently feed on carcasses of hunted animals, and sometimes even animals that were left out intentionally. And they would consume the lead-based ammunition inside these animals, and it was causing lead poisoning, and they were dying. They were also impacted by the spread of pesticides, which was thinning their eggshells, and we'll talk a little bit more about that when we get to the section where I'm going to talk on pesticides next week. In 1980, conservation groups launched an all-out effort to pull the California condor back from the brink of extinction. So they knew that female condors were more likely to lay a second or a third egg if the first egg is removed. So they began collecting eggs for captive incubation. So you can see the picture right here. This mama bird is actually a leather glove that they modified to look like a mother's head. And techniques like that are actually really important because you want to make sure that the young don't get too much exposure to people. You want to keep it as natural as possible. So they would feed him just like it was a mama bird, even though it's a person with a glove. Some birds were also taken to zoos for captive breeding programs. But in 1987, there were fewer than 10 condors left in the wild. So the decision was made to bring them all in for captivity. And when they finally got them all into captivity, there were only 27 left in the world, in all of captivity and the wild. So the reintroduction has been pretty successful. They have done a ton of captive breeding. You can see the population shooting back up here in the captive breeding. And then they started reintroducing them into the wild in 1992. So they reintroduced 7 of them. And steadily with reintroductions, we have had a pretty massive increase. So now their most recent numbers show that there's about 519 California condors alive today. So it's some in the wild and some in captivity. So they're doing much better. It's come far away since 27 individuals, right? And another important reintroduction story is with the black-footed ferret. So though black-footed ferrets sometimes eat squirrels, mice, and other rodents, prairie dogs are essential to their survival. And they make up the majority of their diet. So they will hunt them down in their burrows, and they'll take shelter in abandoned prairie dog dwellings. And many prairie dog towns became kind of ghost towns. Populations underwent a huge decline in the 20th century. And that's mostly because farmers and ranchers, with the government assistance, pretty much eliminated all of the prairie dogs. Their underground complexes were deemed destructive to fields. So they got rid of them all. They pretty much wiped them out. And in the process, their predator, the black-footed ferret, was nearly wiped out. In 1987, 18 animals were captured and in the wild and brought into a captive breeding program, and they believe that was all of the ones in the wild. They captured them all, and they've since reintroduced them into some of their habitats. So the reintroduction efforts have kind of been mixed. Populations need a viable prairie dog town to survive, but they also face threats from like predators like golden eagles, owls, coyotes, and then reintroduced animals also lack some survival skills, so their mortality rate is high because they were raised in captivity. Another major threat has been disease. So the prairie dogs and the black-footed ferret are both susceptible to a non-native disease called the sylvatic plague. And it's been terrible for both prairie dogs and the ferrets. They have developed a vaccine. They've been attempting to administer it to wild populations, but it's a work in progress. It's hard to get everyone to get the vaccine, right? And as new individuals are being born, they are not immune to this disease, so they can die if they get infected. And captive-born individuals are getting vaccinated for this, and they have an 80% chance of surviving. But wild-born individuals have no immunity at all, so a lot of them are dying. As of now, though, there are about 350 ferrets in the wild and another 300 or so in captivity. So they are on their way back, but it's a work in progress. Another species that this is actually considered one of the most, one of the largest conservation reintroduction success stories out there, is the tuatara. So before the arrival of man, the tuatara was present in both the main islands and many of the islets in New Zealand. So when the first European settlers arrived, tuataras were already found in about 32 little islands. And it's believed that the extinction of them from the main island was due to habitat destruction and the introduction of foreign mammals like rats. And other threats included their low genetic diversity caused by their isolation of different populations, and also climate change, which can affect the sex of the offspring. And we'll learn in our climate change lecture that's kind of a theme in a lot of reptiles. So they're currently actually doing pretty well. One of the main tasks has been eradicating the Pacific rat from the main island where the tuataras live. And in order to do that, entire populations of tuataras were captured. They were brought in for a captive breeding program. And while they were in captivity, they removed all of the rats from the island. So after their main threat was eradicated, all of the captured individuals and their captive-born offspring were able to be re-released into their natural habitat without the Pacific rat being there. So that pretty much got rid of their biggest issue. And currently, their wild populations are estimated to be between 60,000 and 100,000 individuals. So this is considered to be one of the greatest success stories of reintroduction programs. Another really great success is the American alligator. A lot of people don't know that in the 1960s, the American alligator almost went extinct. So it had been hunted recreationally and commercially, and they were placed on the endangered species list in 1967. But captive breeding programs and reintroductions of the alligator have allowed their populations to rebound. So they're now least concern, and they have an estimated 5 million American alligators right now. So captive breeding and reintroductions have been a major success here. And there's also one more major success that we all have probably heard of. Well, I know we've all heard of it if you've been doing your readings, and that is the reintroduction of the gray wolf. So gray wolves and a lot of predators were pretty much eradicated from a lot of areas in the United States. There was the whole idea that getting rid of predators would be just a paradise for hunters, right? Because you're going to have all of your deer populations thriving without predators. But they found out that it really wasn't the case. Everything was kind of doing terribly after you got rid of predators. And they decided to, and it's very controversial. Some people are still very adamant that they shouldn't be there. They decided to reintroduce wolves to Yellowstone, and they have been doing pretty great, actually. Their populations are thriving. They have expanded out of Yellowstone and are starting to take back some of their former range. And a lot of people hate this. Especially when it comes to farmers and ranchers, because the wolves will sometimes take down some prey of their cattle or any of their farm animals. So they have been losing some farm animals because of the wolves, and a lot of people now are starting to hunt the wolves again. So even though it's illegal in a lot of areas, there's a lot of poaching going on of the wolves. But I do have a quick video that I want to show you guys, and it really shows how just reintroducing one animal can cause a whole bunch of changes.
One of the most exciting scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years. That the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They'd just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behavior of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds, of migratory birds, started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behavior of the rivers. They began to meander less. There was less erosion. The channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitats. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilized the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and the vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilized that as well. So the wolves, small in number, transform not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
Okay, that's where I am going to leave you guys today. Don't forget that I extended the due date for everything this week, so you have until Saturday at noon instead of Friday at 5 p.m. So enjoy the rest of your week.